Hi folks, Mr. Long here. I'm just going to do a quick little screencast on solving differential equations. These are going to be general solution equations. In other words, it's going to have c, the constant of integration, in it. And they're going to be ones with exponential. So just to do some review so that you understand some of the things that we're doing, what we're going to look at right here is what's the derivative of ln x? So we know that ln x looks like this, right? It has that general shape. It's asymptotic at x equals 0, and it has a slow rise to the right. And so let's, again, just to revisit, if I draw some tangents there, that one's really steep, less steep, less steep, less steep, but always positive. So then the derivative would look like this, right? 1 over x. So the derivative of ln x is 1 over x. We know that. But I have to state x is greater than or equal to 0 because ln x only exists on the right of the y-axis, right? This part here doesn't exist. So if I don't put this, then I'm making a mistake because the derivative can only be defined where the original function is defined. So where does that leave us with integration? Again, pause, rewind, make sure you understand that. So the integral is we have to put, when we do the integral of 1 over x, now we're going backwards, we have to put absolute values around this. Why? Well, if, for example, so just think of this as an antiderivative, the opposite, right? So now I'm going, this is my rate, and I'm getting my original function in this case. If I just did ln x, I would have that graph. But is that actually the graph? Well, no, it's not. It's not actually the graph. So because we've got another part over on the other side, okay? And so what we have is this, okay? So ln x, if I just had ln x, I'll erase that part. If I just had ln x, I would, sorry folks, yeah. So this, and I'll do this in red now so you can see it. So that's ln x, okay, that's ln x. And so, but if I'm doing the integral of 1 over x, it has to have both branches because 1 over x is here and here. So I need an antiderivative on the left side of that y-axis. So what I do is I put an absolute value bar on it, and then I can draw this in. Okay, that gives me both branches. All right, and later on when we solve things with differential equations with particular solutions, it's only going to be the right or the left. But in general, I have to put the absolute value bar to make sure I get the left branch, right? The left branch. Because remember, what that really is, ln of absolute value of x is really just ln x and the ln of negative x. Okay, so that's over here. So if another way to write that, I suppose, would be if you did the integral of 1 over x dx and x was less than 0, so you only had the left side of it, then that would equal the ln of negative x plus some constant c. Okay, because again, the derivative of a y-intercept is 0. Okay, so that's why the integral of 1 over x is the ln of the absolute value of x.